Here we go with our last lesson of unit number 7. This is the second part of the word problems from the previous lesson. Our learning goals are the same. We're going to use sinusoidal functions to model real-life data. And we're just going to do one question, multiple parts, about a Ferris wheel. The first part of the question. A Ferris wheel has a radius of 24 meters and sits 1 meter above the ground. It rotates once every 24 seconds. If people board at the bottom, sketch one cycle and model the motion with one sine and one cosine function. The first thing you should always do is draw a picture. And if it helps you, you can draw a picture of the Ferris wheel with all of the dimensions labeled. So let's do that. Let's say this is our ground. In other words, our x-axis, but we'll get there. And then we're going to draw a Ferris wheel. So there's our very rough Ferris wheel. It has a radius of 24 meters. What's radius? Radius is the distance from an edge to the middle, right? So we know that from there to there is 24 meters. It sits 1 meter above the ground. Okay, well, we know that from here to here is 1 meter. It rotates once every 24 seconds. We'll get to that. People board at the bottom, sketch one cycle, and model the motion with one sine and one cosine. Okay, so there's our picture. Let's make a y-axis, and that's going to be height in meters. And then our x-axis is going to be time and in seconds. So we know that if a rider boards at the bottom and they go around, the lowest height they'll ever be above the ground is 1 meter, right? At the bottom of the Ferris wheel because it's 1 meter above the ground. So let's say right there is 1 meter. What's the maximum they'll ever get? Well, we know the radius is 24, which also means from there to there is 24, which means our diameter is 48. Plus 1 above the ground, right, is 49. So right there is 49 meters. And then in the middle, that's the center of our wheel, that would be 1 plus 24, which is 25. So we've already come up with a lot of the key information without actually knowing it. Now, it rotates once every 24 seconds. So somewhere over here, we're going to write 24. Remember, sinusoidal functions are perfectly symmetrical quarters. You can split it into equal parts of 4. So what's 24 divided by 4? Well, it's 6. So that means that we have increments of 6. So roughly halfway would be 12, halfway there would be 6, halfway there would be 18. Again, just to stress that, you can always split your period into quarters for sinusoidal functions. Now we're ready for our graph. I like to draw the lower limit as well, just to give us a target to hit, and the upper limit. People board at the bottom. Okay, that's right there. So there's our point. At time 0, they're at the bottom. And we're going to assume that if you're at the bottom, you have nowhere to go but up. So every quarter you go up. So we'll kind of do this here, assuming it rotates clockwise. There on our Ferris wheel is our first quarter. We hit the middle mark after 6 seconds right there. Then we go around. We hit the top halfway, 12 seconds. Then we start our descent back to the middle, 18 seconds. Then we come full circle, back to where we started, 24 seconds. And we can now draw a smooth curve. Now we don't have an arrow on the other end because you can't go back in time, but we have an arrow on the right side because this keeps going on forever. Even though I said sketch one cycle, I guess I shouldn't have put the arrow there, but I just wanted to indicate that it does keep going on and on forever, or until the Ferris wheel stops. So let's model this with one sine and one cosine function. So let's start with our amplitude. Max minus min. 49 minus 1 divided by 2, 48 divided by 2 is 24. Well, we see 24 somewhere else. Where else do we see 24? Our radius. When it comes to Ferris wheels or other circular motion questions, the radius is always going to be your A value or your amplitude. So there's our A value. Let's do equation of axis. Well, that's just max plus min divided by 2, which is 25. That's the center of our Ferris wheel off the ground, or any other circular motion question. So there's our C value. Our K value, we know it relates to the equation P equals 360 over K. What's my period? How long does it take to do one full revolution? Well, it takes 24 seconds. So K equals 360 divided by 24, which equals, what is 360 divided by 24? 15. So K equals 15. So let's start with a sine function. And I'm just going to say, you can use f of x. I'm going to use h for height and t for time. So this is actually h of t. So A value, 24 sine 15 t, which if you use f of x, put x in. We don't know our phase shift yet, and then plus 25. Okay, so let's come up with our phase shift. And I'll take out a different color here. Let's use yellow. For point of reference, sine normally starts there and goes up. It starts on the equation of axis. So there's my equation of axis. Clearly that's not where my function is. It's been shifted right, and in this case 6 seconds. Right, 6. If you don't like that, you could go all the way to the other time, which is at 18, but since you're going down, you can make it a negative out front. I'm going to stick with what's easy, right 6, so t minus 6. Now let's do a cosine function. Same thing, 24 cos 15. T, don't know my phase shift yet, plus 25. Cos normally starts at your max and goes down for reference. Pick a different color here. Pick green. So cos normally starts at your max, goes down for reference. Well, my max is here. That's as high as I get, 49. But I'm not on, my function's not on the y-axis. It's been shifted to the right 12. So that would be minus 12. And I'm going down like I should be, so I don't have to worry about making it minus. Perhaps even simpler than that. Instead of having cos start at the max, what if it started at the min down here? Well, there's my coordinate right there on my function. I didn't shift right or left at all. But I'm going up now, so that means I'd have to make it a negative 24 cos. But then you'd have no phase shift. It would just be negative 24 cos 15t plus 25, done. So there's our equations. Now I've put the graph back up there just so we can see it, so I don't have to redraw it, because we're going to use it. How high is the rider after 10 seconds? When else is the rider at this height? Well, I've given you a time, 10 seconds, that's t. So let's just pick, it doesn't matter which of your two functions you pick. I'm going to pick the sine function, but it honestly doesn't matter which one, you'll get the same answer. So I, h of 10 equals 24 sine, this is just using our function we came up with, replacing t with 10, plus 25. Make sure your calculator is in degree mode, and you enter in your calculator just like you see it. You can actually put it all in one step if you want, that's okay. Obviously the downfall is, if you do that and you make a mistake, I can't give you part marks because I don't know where you went wrong. So I'll leave it up to you though. Rounding to 1 decimal place, I get 45.8, and it would have been meters. Eyeballing it from our graph, 45.8, so there's, on our graph, there's 9, right? So 10 seconds, roughly there. If we could trace up, yeah, that makes sense, roughly about 45.8. Looks good. I. When else is the rider at this height? So I'm going to erase what I just put in there. Okay, so let's say there's, okay, I'll put the 9 back in, I guess. So there's 9 and there's roughly 10 right there. And again, if we trace up, we're roughly there. And we know it's 45.8. When else are you there? Well, you are also there, right? 45.8. We are also there, right there. What is that time? Well, we don't have to guess. We don't have to guess. The beauty of sinusoidal functions. They are symmetrical and they are split into quarters. So you got to pay attention to this. It's a little bit of an abstract thought, but once you get it, it's really not that bad. The middle of my graph right here, going all the way down, is 12. How far away is 10 from 12? So how far away is this to this? That's 2 seconds. It's symmetrical. So if I'm 2 seconds away here, I'm also 2 seconds away on the other side. What's 12 plus 2? Well, that's 14. Another way that you could think about this symmetrically. Here's my beginning. How far away is 10 from the beginning? It's 10, and it's symmetrical. So I could go 10 this way, 24 minus 10, 14. So for part 2, all you have to do is say, by looking at the graph, and maybe you have a little sketch like I just made. So by looking at the graph, and using symmetry, right? We use the symmetry, the symmetrical nature of sinusoidal functions to get these. We get 14 seconds. How could you double check your answer? Put 14 into your function, you should get 45.8, which we do. If I asked you for like 2 more times, all you have to do is add the period. What's our period? Our period is 24 seconds. So we could take 10. What's 10 plus 24? Well, that's 34. And we could take 14 and add 24. What's that? That's 38. And those we got by doing 10 plus 24 and 14 plus 24. Remember, 24 was our period, which means it's going to repeat every 24 seconds. Hopefully that makes sense. If it doesn't, listen to it again. This is a really important concept. Once you grasp it, though, it makes life so much easier on yourself. I. When is the rider 13 meters above the ground? Unfortunately, 13 meters is not, this is going up by what? 5, 10, 15. So 13 is like kind of there. And we'd be kind of guessing, right? So we have to do a calculation here. Let's use our function again. So our function was h of t equals 24 sine 15t minus 6. Again, I'm just using the sine function. It works the exact same for cosine, if you chose to use it, plus 25. This time I gave you the height, and I asked for the times. So I gave you h of t, which is 13. And we have to free the t. Step number 1. Bring over the 25. What's going to happen to it? It's going to become minus 25. So 13 minus 25 equals 24 sine 15 of all that stuff. What would be the next step? The next step would be to divide both sides by 24. Okay, so I'll do that calculation. 13 minus 25, negative 12 over 24 equals sine 15t minus 6. So we've slowly started to peel back some of the layers to get t by itself. In the last lesson, I showed you how to do cast rule, like going back to our trig equation unit to come up with these values. You can also just use your calculator. What's the opposite of taking the sine of something? Sine inverse. What's the opposite of cosine? Cos inverse, which remember you get to those using the shift or second function on your calculator, and usually it's written in yellow or orange ink above the sine and cos button. So what we're going to do is we're going to sine inverse both sides. Okay, so sine inverse, sine inverse. And what that does on this side is it gets rid of those things. So we're going to have the sine inverse. Now negative 12 divided by 24 is just negative 0.5 or negative 1/2. And then 15t minus 6. And if you use your calculator, sine inverse, so shift or second function sine, of negative 0.5 is negative 30. And now that we've done that, we've done the hard work. This is a simple equation to solve. Divide both sides by 15. And you get negative 30 divided by 15 is negative 2. So we'll continue up here. Negative 2 equals t minus 6. Bring that negative 6 over. Negative 2 plus 6 equals t. 4 equals t. We did it. It looked complicated, and it was kind of complicated, but it wasn't too bad. We were able to do this. And if we look at our little sketch we made, again, we don't know, we're kind of guessing, but yeah, that kind of looks like it roughly is 4. That makes sense. Based off of just our one cycle, though, there is actually 2 times. So there are 2 times that they are at 4 seconds. And we're going to use symmetry again. 13, I hit it if I draw all the way across. I hit it again right there. Well, if from here to here is 4, and I know this is symmetrical, then I should be able to go 4 that way. What's 24 minus 4? 20. So it's at, the rider's at 13 meters. So therefore, at 13 meters, when t equals 4:20, and we could keep going. Add the period, add 24 seconds. What's 4 plus 24? Well, that's 28. What's 20 plus 24? 44 seconds. And you can keep going. So it's right, and so on. Hopefully that makes sense. We're okay with this. I don't care if you use the cast rule. That's probably a bit more complicated than what I did here for you doing the sine inverse, or if we use the cos function, the cos inverse. If this makes more sense to you and is a little bit more manageable, awesome. So on your test, you will definitely have a few word problems. I can guarantee you one of them is going to be about Ferris wheels or something circular, maybe a hamster wheel or something like that, but it will be something circular for sure. So that is it. I'm sure some of you have a little bit of a nostalgic tear in your eye because this is your last video lesson for a lot of you. So like I said, there's a bonus unit coming up. It is completely optional. And to be honest with you, there's like, as of publishing this, there's like 6 or 7 of you that are above 95. If you're above 95, you doing the bonus unit really is not going to make that big of a difference on your mark, to be honest. So if you chose not to do it, I wouldn't blame you. Or there's going to be some of you who are perfectly content with what your mark is and you would rather prepare for your 30% final. And that's perfectly okay as well. So this is technically your last, for those people, your last video lesson. I don't know how many people are going to listen to the bonus video lessons or take me up on that offer of trying to improve your mark that way. So I'm just going to say thank you to all of you for being a great class. I know that this was less than ideal for some of you, and for others, it was, it was good for you. Again, I love being in the classroom. That's, where I would much rather teach, and I'm sure you would much rather learn. However, even though I didn't get to know you all that well personally like I would in the classroom, I could definitely tell with some of you, with most of you actually, that, partway through, with some gentle nudging and pushing, you made adjustments. You reached outside of your comfort zone, and the results improved, and you proved to yourself that yes, you do have the ability to have some resiliency, to try new things, to look at an obstacle and try to overcome it as opposed to looking at an obstacle and getting stuck at it and then, pointing the blame in different directions, so to speak. A lot of you throughout the quadmester, you started asking more and more and more questions, and again, that had a net positive result on a lot of your marks. So again, thank you for putting up with these. Thank you for doing what I asked of you. I am proud of you. You should be proud of yourselves. If you can look yourself in the mirror and you can honestly say to yourself, I gave it my all, that's all I can ask for. And hopefully come September, we will be back in the classroom and at some point back to normal. Maybe we can even shed the masks and do some group work. Who knows? But until then, good luck with this unit test. If you choose to do the bonus unit, good luck with the bonus unit. Good luck with preparing for your final 30% thingy. Good luck with your other courses. And I'll say this again, there's going to be, aside from the bonus unit, there won't be any other video lessons. So there won't be any video lessons for the exam or the 30% review. But I still will be on Teams every day like I have been all quadmester from 10:30 roughly to 1:30 to help you if you need help with any of those things. So don't forget, I'm still there. I will send messages through Hasia and email, but just to kind of give you a little bit more of a personal touch, I guess, as a, just my voice as opposed to text. Have a great summer, and I do look forward to seeing you all in some sort of normal capacity in the fall. Again, thanks for listening. Happy mathing.